Now we're going to be looking at multiplying and simplifying radical expressions. Our product rule. If a and b represent non-negative real numbers, then square root of a times square root of b is equal to the square root of the product of ab. Or, big or. If I have square root of a, now normally you won't see it as a two separate factors. We have to make it that way. But if I've got a number that I can split up, then I can simplify the expression. So in the first one, I've got square root of 2 times square root of 5. That's the same thing as square root of 2 times 5. Or you could go ahead and just say square root of 10. In the next one, I've got square root of 7 times 11. That's 77. X, y. And it's all under the radical. In the next one, I've got square root of 7 squared, or you could look at it as square root of 49. Whichever way, square root of 49 is 7. If you remember, this is a 2. And back in the last section, we could write that as a fractional exponent. And 2 divided by 2 is 1. Let's see in this one. Square root. My numerators, I'd have 6. My denominator, I would have 35. Now, the next part, we've got to simplify by factoring. And this is where we're going to look at this end of the rule. So, down here, the key is to find a factor that is a perfect square. And this is why you really need to know your square roots, because it does help. In this one, 75, that's the same thing as 25 times 3. I can take the square root of the first one, which is 5. But the 3 has to stay on because it's not a perfect square. Now 80. Let's look at 80. We want to look at it a couple of different ways. Let's see, 4 will go into it. I know that. When you start breaking a number down to smaller numbers, then you can see if it's got some more perfect square factors. So I'd have square root of 4, which is 2, square root of 4, which is 2, and then the square root of 5 has got to stay on, so that would simplify to that. Now if you looked at that and you knew that that was square root of 16 times 5, then you could have gotten down there faster. But there's not that many people that notice that. Let me see, 38. I know 2 will go into 38. 2 times, let's see, that would be 1, 9. Neither one of those is a perfect square. So square root of 38 is stuck as a square root of 38. And you can check yourself on these to see if you simplified correctly. I'll look at square root of 80. Move my calculator. So let me do square root of 80. See what it is decimal. And if I go 4 square root of 5, it should come out to be the same thing. So I can check myself on those. Simplifying with variables, even powers. Now on x to the 6, if you'll notice, they're trying to show on this, you see that's x squared, that's x squared, that's x squared. And since these are perfect squares, then you can take the square root of each one individually, like I did up here. Another way to look at it, though, is if I rewrite that as fractional, a rational exponent, that would be actually x to the 6 over 2. So there's your x to the 3rd. So in a way, if you're doing a square root, if your exponent is even, you're technically dividing by 2. So let's look at this one. So that would be x to the 10 over 2, or x to the 5th. The hardest ones on here will be your numbers that you have to simplify. So let's see. If I divide 2 into 72, 2 into 7, we'll go 3, 2 into 12, 6. So I'd have 36, and I'm going to put a times sign here. I always put the perfect squares up front, so I know they're get to come off, but the ones behind the times sign are stuck. Since that's even, it's going to get to come off completely. Square root of 36 is 6. X, 14 divided by 2 is 7, but square root of 2 stays. So that's my final answer. Pause me and you try to do this one. So 2 wouldn't help me because it's 2 times 20. So try another perfect square. 4. 4 into 40 will go 10. Now the 10 is going to be back here, but the 4 is a perfect square. Square root of 4 is 2. Square root of x to the 16th is x to the 8th. And that would be my final answer. So practice these.